In part 4 of section 12, we're going to look a little more closely at the idea of the maximum and minimum value of a quadratic function. Now, we've discussed that with a quadratic function, there's really only two options in terms of the direction that the graph can go. We will either get a graph that opens up, or we'll have a graph that opens down. And the graph is always parabola shaped, and these are the only two options that we have. When we're looking at the parabola that opens up, the vertex is located at the relative minimum. When we're looking at the parabola that opens down, the vertex is always located at the relative maximum. Now, this theorem is going to help us to see a little bit of that, but it does even more than that. It also gives us a shortcut on how to be able to calculate the exact location of the relative min or the relative max, which by virtue is a shortcut for calculating the vertex. So it says the maximum or minimum values of a quadratic function represented in standard form, so we have some standard form equation, occurs at x equals negative b over 2a. So what this is saying is that you have that vertex point, and that the vertex point is going to have some x value, and that x value is going to be negative b over 2a, which is what we traditionally will call the h value. So negative b over 2a is a way of calculating h. Once you figure out what h is, then you can take the value of h and you can substitute it in to the function, which is what we're calling here f of negative b over 2a. So f of negative b over 2a is really saying f of h, which is going to be known as our k value. So back over here on the relative minimum calculation, the y value for the vertex is going to be f of negative b over 2a, and that's going to be known as the k value. So this gives us a shortcut for calculating h and k. We don't necessarily have to use complete the square to turn standard form into vertex form in order to figure out h and k. This will do it for us. And then the rest of the theorem says that if a is greater than 1, then that means you have a minimum value. Well, if a is greater than 1, then we know that our parabola opens up. So basically, opens up means minimum, and then if your a is less than 0, in other words, your a is negative, that means that your parabola opens down, which we know means there's going to have to be a maximum. So this gives us not only some insight about the minimum and maximum, but it also tells us a shortcut for calculating the vertex. Very powerful theorem, and we will see some examples coming up where we will use it.